let's go back to this page. Let's do some more of these, and then we'll talk about some. We'll go back to the polynomial division, dividing by monomial, and then how this will look on the SOL, and then we'll have some kind of things. Okay, so we did 1 and 2, 4 and 5, but I don't think we did 6 or 7. Okay. Alright, if we were doing 6, we have to recognize what type of factoring is going on. We have 4 terms, so we're factoring this in what way? Say that one more time. So not for number 6, for number 7, yes. So difference of perfect squares or difference of squares is just 2 terms. We have 4. There's only one factoring method with 4 terms. What's that called? Look back in your notes.
Oh.
Not in these ones.
Can you give me a hint? Like what number to start with?
G.
It is not factored?
No. Yeah.
So what is
What type of factoring are we going to use here?
grouping?
Grouping.
Oh, let's go.
Factor by grouping.
Ah.
Used. So the only time we have 4 terms is when we factor by grouping. So split that down the middle. Find the GCF of both sides. What would that be for this? M to the second power. Leaving 4m minus 1 minus 1. What would the GCF of the second 2 be?
And negative.
Plus n. No, positive. And what would be left?
4m.
Okay. Remember to put all of that over m squared plus n. And then rewrite this as your 2 factors. M squared plus n and 4m minus 1. When we cancel out those like factors, what's left? 4m minus 1. Make sure you are actually canceling out the like factors. That was basically a piece of the A doesn't equal 1 trinomial, but just the grouping aspect. You might see some of those. And then for 7, we are going to use our difference of squares. How would we factor this numerator using our difference of squares? You might have to look back at your notes.
Oh, what does it start with?
That's a good question.
Do we never?
There are factors. Does it have a GCF?
Oh, so
Yes.
No, we don't want square today.
We divide new.
Not yet.
Hmm?
What did you say?
Has a little white thing.
Not yet.
It's like on the top.
I did.
So we are doing difference of squares. Think about how we factor using difference of squares.
Oh, look at that. What is difference?
Look back in your notes. That was one of the first things we learned about when we learned about GCF and difference of squares. Look back at that.
Oh, make them.
We do make 2 factors, yes.
Foil?
No.
And then, like, find the GCF of 2.
There's no GCF.
No, find the.
No, we did.
You guys will have to be able to do this. That's what I'm saying. Look back in your notes. Find how we factor difference of squares.
It's not find something that goes with one. That's something that goes with
Something like that.
Oh, what are you talking about?
Separate it how?
Yeah, but separate it out.
I'm not saying that's wrong, I'm just asking more about that.
You just put the numerator on the left, the denominator on the right?
No.
Okay, alright.
Oh.
How far back are we talking?
The first day we learned about factoring. We learned about GCF and difference of squares.
Well, that's in there right here.
I don't know. That's how I've seen a lot of them.
Wait, is it on the wall?
What?
This is not helpful.
Oh, so I see factoring there. Oh, it's right there. Oh, shit. I can't read it.
It is in those
Oh.
ones.
It doesn't explain, but there's like two. Like you have there, and then there's two variables on the outside. Oh, we, never mind.
Ridiculous.
This is kind of fun to watch.
The fun.
I think the one that's the same. I'm not for sure. Is it M2 minus? Is it difference of squares?
I just said that.
Say that one more time, sir.
Is it M2 minus? M2 the second power.
Isn't it like m times m minus? No.
I
Is
feel
it-
like you might be on the right track, but that's not how we would write it.
Is it perfect square trinomial?
So
Difference of squares are perfect squares, yes.
So then 1 times m squared minus 9 and then no.
Do either of you have an idea? So that
What is it?
Where is it?
Don't like that
It's
same
similar
thing.
to that, but use what we have here.
Is it M on the outside, and then M minus 9, and then M plus 3?
We're putting stuff inside here, nothing on the outside.
Oh, the numbers that go outside, they're on the, in the That's what I'm trying to say, so.
M squared
We
minus
don't, for this one, we don't put
Wait,
anything on the
is it
outside.
negative 9? Is it m squared?
minus 9.
It's not m plus m. We're not using the 9 when we put it in here now.
Also 2 m squared minus 3.
We're not going to put m squared either.
Then it's m plus 9?
We're not going to use the 9.
M plus 3.
Okay, that's one of them.
And m minus 3, right?
And m minus 3. Difference of squares. What times what will give you each piece? Split it.
I said that. I said difference of squares.
I said difference of squares is perfect squares.
Oh,
So do we just ignore the 9?
No, say.
I mean, if I multiply this back out,
Right, it equals to
It
9.
goes so then if we cross out our like factors,
m minus 3.
M minus 3.
So she's the denominator?
no.
Okay.
So you have to be able to recognize all of the different factoring methods so that you know how to factor. Because if you factor this wrong, you won't get the denominator. And then things will be messy. Okay? Questions there? Okay. I think I had you write down a problem. I don't know if I still have said problem. So if someone has that wrote it down, tell me what that is. We'll do that one.
You sort of square back
With the x squared,
to.
you want to say negative?
Over 2.
So not this one. It was like
Y.
the one
Y
with y.
squared plus 1 over 2y.
And this is one over 16.
Yeah.
It's not that one either. So not the one with
That's the only one you
I thought I had a 12 in it somewhere.
that one. Tell me what that is. X to the third power.
Y to the second power. Plus 7 times y to the second power.
Y to the second power.
Yeah. Yes. Minus 7 is y. All over 7 is to the second power y.
Yeah, write that down. Here, write this down. somewhere where you have space. This is going back to the dividing by monomials. Because I'm going to show you why maybe GCF won't work here, and you want to separate it instead. So let's say we did find the GCF. What would that be?
7.
7y. If I start dividing that out of the numerator, what's left?
7.
2 x third y.
No, y plus y, just y.
Plus
X
X, y.
minus
4 y.
No,
no, just
y,
4.
no,
Just
y.
4.
Normally when we do these are the same, but they're not in this case. This would be a good time, if you see something like this, to be like, maybe I should separate it instead. You could still do the GCF, but I'm going to show you what happens.
You want to start at each function?
We're working on the problem, yeah. So we're still going to divide those two. Leave everything else in parentheses.
You want to start that then?
Yes. You're solving the problem with this. So if we divide out that fraction, how would that simplify? We would just have x squared. The 7 and the y would cancel, but the x squared would stay in the denominator. And when you get something like this, you're going to have to multiply that 1x squared back. Or the 1 over x squared back. We have
7x.
I'm just going to write it like this, and then we'll simplify. Plus xy over x squared minus 4 over x squared. I'm going to simplify next. You could have simplified at the same time. I'm just showing each step so you don't get lost. So then I could simplify both of these. What would this simplify to?
7x y.
Okay, the next one.
X.
You would have 1x, but not in the numerator.
Would it be 1 over x?
The y wouldn't disappear.
1 over x.
And then this wouldn't simplify. And that would be your final answer. So while you could do that, you'd have to remember to distribute it back and simplify. If you just started off separating, then you would end up with this right off to that. So let's do that. So we're going to start with the problem again. The original. And we're going to separate each piece. So 14x cubed y squared over 7x squared y plus 7xy squared over 7x squared y. I think that was a minus 1 plus. Minus 28y. And then just simplify each piece. So if we simplified this, what would that be?
7. Just 7.
It would be 7xy plus
X.
would be y over x minus 4 over x squared. See how we got there a lot faster?
That's easy.
Yeah, either one was the answer. So you could do it by GCF, but if you see that what you factored out and the denominator are not the same, you'll have to simplify it, multiply it back in, simplify each piece, or you could just start over and divide everything separately. What questions do we have on that? Go grab an iPad if you don't already have one. Go into Desmos.
Mine was like.
So are you the first two?
Alright, and then we're going to try a couple of these in Desmos. So we talked about this when we were doing SOL practice, but now that we've actually learned how to do it, you're always welcome to do this by hand, but this is how you would do it in Desmos. Go ahead and put in 16x squared plus 40x plus 25. You should have this in your notes if you want to start.
Oh, you have to exit out the app and then reload.
Once you have typed that in, go ahead and start typing in your answer choices in separate lines. Yes.
Mine, I grabbed it, I put it in the calculator, and it's not on the one that you was. It's like right down here.
So when you graph your original and you graph your factors, when it's asking which is a factor, you could factor it. That is a good way to see which one is a factor. The shortcut way would be to look and see which of these cross this shape. We'll talk about this soon, tomorrow actually. Which one crosses this shape at your x-axis? And there's only one. And then by default, that would be your answer.
Just give me said this on the test.
on parts of the Unit 10 test, not Unit 9. But for the SOL coming up, you need to not do this. What you could also do as you're factoring, when you're double checking, is just to put it back in. So I'm going to go back to the number 7 we did. If you have different variables, change it to x and decimals always. If I were to put in what we factored, so I'm just going to put the whole thing in altogether. I forgot this is huge. Any of your division problems is going to give you a line. That's because our like factors canceled. You could count the slope and find the y-intercept of that line. So I know this starts at -3, my slope is 1, so if I type in y equals x plus 3 minus 3, or got rid of the y equals, they should overlap. And that would tell me what my factor is. You could do that same thing on the calculator. You just won't be able to see it clearly. And the same thing we did before, putting in all the answer choices. You could do that in the calculator as well.
Did I do that to x minus 3?
Yeah, number 7, I just switched the variables. So if you try to put any other variables in here, it won't graph it. It has to be x. All right, questions on how decimals works? Anyone need or want to see it in the calculator?
This is just how to check if you're right or not.
How to check for factors, how to check your division. Okay. I'm going to put out the quiz. This is not as a grade as if you want to just practice it prior to the test in May. We are going to review prior to that. But I'll put that out so you can work on that. You can work on Delta Math, JLabs, SOL practice, your Math Gab packets you now have. So if you want to keep doing that, keep coming to get it checked, maybe individually, not as a group, you can keep doing that. So you have more SOL practice. The SOL practice that's due on Monday, 6C through 7D. Your JLabs, Delta Math that's due tomorrow. You have a bunch of different practice you could be working on. Work on that. Questions on what we're doing for the rest of the class? Okay. Use the time wisely. No cell phones until like 15.